Hello, welcome to revision once again. So, obviously, the exam got delayed, because of course it did, which means the last two revision streams that I've done were kind of useless. So what I'm doing today is I'm going to recap everything in maybe, 20, 30 minutes? I don't know how long I got here. So, what we'll do is we'll just go recap everything from the topic. This looks like some Madman drawings. I know it does, but it, we'll be able to decipher it. In fact, you know what we'll do? We will go and rewrite everything. I will wipe all of this out, which will be easier said than done because some of this has been on here for 2 weeks now. I'm going to wipe out all of my crazy man drawings, and we are going to redo it. We're going to redo the revision. Oh my god, this is so tough to do. This is kind of a good lesson. Don't write stuff on your whiteboard and then leave it there for 2 weeks. Right, so some guy's going to click on it and be like, what the hell is my guy doing? So yeah, the topic is proteins and enzymes. Proteins, obviously, we'll get into first. Faith actually sent me a message asking me what topics to do, I guess. And she basically listed all of them, although she actually included some stuff that I forgot to revise. She actually revised some things that I didn't revise. So I might include some of them here as well. The things she revised that I didn't, I think she did percentage increases. Basically how to figure out the rate of reaction. And I think she put monosaccharides there and polysaccharides, which I didn't understand because the exam's on proteins, but it might be worth maybe quickly glancing over at some of the previous topics. Because we might get a combination question. We might get a question where it asks us to talk about the different structures of X, Y, or Z. Or it might be one of those matchup questions I've shown you guys before. So who knows? Anyways, let's start off with the amino acid. And I do not recall the structure. I believe it is this. It is a... Is it a carbon? Okay, I'll be totally honest. I forget the structure of an amino acid. I'm gonna say that this is it. This is my guess. I think this is roughly what the amino acid looks like, but this is an amino acid. Okay. Now, an amino acid is, I guess, a monomer, and the idea is that it bonds via condensation to another, and obviously condensation involves the elimination of a water molecule. So if we get one of these here, if we get one of those, then what we see happening is the hydrogen from the amine group and the OH from the carboxyl group basically get removed, and this allows it to join up with another group, well, another amino acid. Like so. Now, the interesting thing to note, this is obviously a peptide bond, and it's joined together via condensation. Okay, so the interesting thing to note here is that when multiple of these join together into a chain, this is called a polypeptide chain, and this is the primary structure of a protein. Now, basically, I don't exactly recall how this works. I'm pretty sure that on either end of a chain, hydrogen bonds form, And these hydrogen bonds cause it to coil or fold. And this moves us on to the secondary protein structure. So the secondary protein structure is when both hydrogen bonds formed at the end of a primary structure fold or coil. And it either folds into an alpha helix or a beta pleated sheet. One of those. So alpha helix, beta pleated sheet. And then from there, the folding continues further, or the coiling continues further, and that's where we get our tertiary structure. Now, there are three main parts of a tertiary structure, and tertiary obviously meaning three. So, good thing to remember there. Number one is hydrogen bonds, number two is ionic bonds, and number three is the disulfide bridges. So let's break those down. So the hydrogen bonds obviously continue to persist, and these hydrogen bonds are relatively weak. Ionic bonds, they are formed between positive and negative charges. You have to remember this, there are positive and negative charges that exist in the protein. There was a very interesting question that I got asked in one of these past papers, and it was kind of like an electrolysis question. It was really interesting, and I probably could have gotten full marks if I remembered that there were ionic bonds. Now, ionic bonds, and you should probably mention this if you're going to talk about enzymes denaturing, the positive and negative charges are easily broken by a change in pH. And next is disulfide bridges, which are only formed between I don't recall the name, it's right on the tip of my brain. The cysteine amino acid. And obviously that is two sulfur atoms joined together. Which is why it's called disulfide bridge. It's kind of joining them together like a bridge. And that is a very important thing to talk about in enzyme denaturing as well. Very important thing to talk about. If you're going to talk about denaturing, you could mention a change in pH could affect the ionic bonding. Change in temperature could affect the disulfide bridges, causing the structure to change shape, so it is no longer complementary with the substrates. And finally is the quaternary structure. This one is basically just a couple of tertiary structures kind of bonded together, joined together, not bonded together, like that. That is a couple of these joined together. And that is the structure of a protein. That is the structure of a protein. Now, let me just try and think if there's anything else we need to do, because I was able to get through that in 5 minutes. That is a big chunk of a topic in 5 minutes. Okay. You might get asked, and I've seen it appear a handful of times in an exam question, maybe 3 times, so it's quite common that this will appear, is a question where it's talking about 2 proteins, you got A and B, but they are made up of the exact same amino acids. So how come they're different? How come they are made up of the exact same amino acids, but their structures are different? It's pretty obvious. The primary structure of a protein affects the tertiary structure. Basically, and I actually dropped a couple marks for giving a complex explanation, so I'm going to try and explain it as simply as possible here. Basically, if the amino acids are arranged in a different order, that means that the primary structure is different, and thus, the tertiary structure will be different. And that's basically all there is to it. If you want to go a little bit more in detail, you could say that there could be different linkage of ionic bonds, but I wouldn't really go that much in depth. You just mentioned that different structure because of a different primary structure. And you could maybe mention an alpha helix. You could maybe say that its secondary structure could be different too. Just make sure to, make sure to keep it simple. Okay. Now, again, I have gone through a shit ton of past papers here to try and find key bits of information that I myself would get wrong. So, not only are these streams good if you want to quickly just catch up on some knowledge, but I've added bits which I've just done there, which should help you if you get an exam question. Because again, a lot of the past paper questions will probably appear. Our teacher literally reuses past paper questions. So it is very likely that we're going to get asked a lot of this. Okay. So that is everything to do with proteins. So let's move on to talking about enzymes. Now, enzymes are basically just biological catalysts. So what that means is they increase the rate of reaction. Now, an enzyme, you could draw it like this. And this is the lock and key method, where you have your enzyme here, you have the active site, this little gap, then you have the substrate. And the idea is that the substrate binds with the active site. So let's draw another one just to illustrate that. It binds with the active site. And then what happens, and this bit is a fact that many don't know, myself included. I did not know this, but this is how it works. The way that activation energy is reduced by an enzyme is via the bonds bending. So the bonds in the substrate bend, or the active site bends the substrate's bonds. This reduces the activation energy required for the reaction to occur. So it reduces the activation energy and you get your product. I'm just going to quickly check. You are a twat, thank you. So it reduces the activation energy. And that's basically all there is to it. There are two different types of enzyme model. You have a lock and key, which I'm pretty sure is no longer used. Like, I'm 90% sure people don't use this one anymore. Which makes sense because there is a better model called the induced fit model. The idea is that the active site changes shape very slightly so that it is complementary with the substrate. So I'm just going to go put down a couple of keywords here. The active site, you obviously have to mention. Substrate, yes. Obviously mentioned the bonds breaking. Complementary. That is a key word that everyone forgets, myself included. I cannot tell you the amount of times that I've forgotten a word. Somebody paid me $10 to say that. Lovely. Okay. Brilliant. Okay, complementary, and then I don't recall anything else. I don't recall any other keywords. Active site, the substrate, the bonds break, complementary, denature. That is a very obvious word again, but people forget. If you increase the temperature or increase the pH, like I said here, the ionic bonds, the disulfide bridges, the hydrogen bonds will get affected. The tertiary protein structure of the enzyme will get affected, which means its active site will no longer be complementary. Literally, these 5 words right here, the camera's not focused, great. These 5 key words, you use them in an exam, you guarantee you get marks. I've checked like about 5-10 mark schemes, guaranteed you'll get marks for just mentioning the words. Complementary, denaturing, bonds break. It's literally just a little glossary, a little dictionary that guarantees you marks. The final part, and we will use a purple pen for this. I don't know why I have so many coloured pens. Is enzyme inhibition. Okay, so the idea is that you have 2 different types of inhibitors. You have non-competitive and competitive. So competitive enzymes bind directly to the active site, and this prevents substrates from binding with the active site. So it basically uses up the active site because it is complementary, and this means that no more reactions can occur in the enzyme because the active site's used up. Non-competitive bind with a different site of the active... they bind with a different site other than the active site. So I think there's a site called the inhibition site. It'll bind with that instead. And what this does is it causes the active site to change shape so that it's no longer complementary. So it doesn't come into contact with the active site, but it still affects it. So those are inhibitors. Some more key things quickly. There are different ways to increase a rate of enzyme activity. One of these is an increase in temperature up until a certain point where it denatures. Same with pH. There is one where if you increase the amount of enzymes, obviously the amount of active sites increases, which means it can bind with more substrates. That is until obviously there are no more active sites to bind with the substrate. So it only works so long as there are enough enzymes. Or basically the way... No, I've said that wrong, I'm sorry. The way to say it is the more active sites there are, it increases the rate of reaction up until there are no more substrates to bind with the active sites. So basically for these two, it's just the active site is used up. And that's why the graph plateaus out. Okay, well that's it. That is everything. I am 99.9% sure that that is everything. We could do the biurea testing quickly. That one is really easy. You add biurea solution to the liquid sample. If it goes purple, that means there is a positive protein. It's literally triple P. Purple is positive protein. That's the way I remember it. Might be useful for you guys. That is all that I really can recall. So, without further ado, let's do some exam questions. I'm not going to draw anything now on the board. I cannot be asked, quite frankly. So let's just go check. Do we actually have any? Okay, we do. I love that guy that just commented you're a twat. I agree, mate. Okay. Name the chemical element found in all amino acids that is not found in triglycerides. I mean, this one is pretty obvious. It's nitrogen. That is found in the amine group, nitrogen. Oh, I forgot to mention a little exam thing that may appear. The R group is always different. Every amino acid has a different R group, but they all have the same amine group and carboxyl group. So if you get asked in an exam what part of a protein differs, it's the R group. Okay. She is not giving many protein questions here. Oh shit, I forgot a really important word. Enzyme substrate complex. Oh my god, how did I forget that? Enzyme substrate complex. That is such an important term. That is an enzyme substrate complex. You mentioned that, you always get marks. Let's continue. The diagram shows the structure of amino acid serine. Draw a box around the variable R group. So you have the amine group, the carboxyl group, then you have a group which is not any. So that is it. Great. Draw Oh, I got those mixed up, by the way. It should be the other way around. Draw a circle around each part of the sodium molecule, which will be removed with two other. So it will be the OH from one and the H from the amine group. Draw a circle around each part. Which two substances are formed when two amino acid molecules join together? I am not too sure. A water molecule would be one. And could you say peptide bond? Would that be a substance? I don't know. That's a good question. Name the type of bond formed between the joined pair of amino acid molecules. It's a peptide bond. Explain how a change in the primary structure of a globular protein may result in a different 3D structure. That one sounds really complex, but it's basically what I just said here. If you change a primary structure, it affects the tertiary structure. So a change in the primary structure of a protein means a different arrangement of amino acids. This means that the tertiary structure, there'll be different interactions between the amino acids, and thus a different 3D structure. And that is every question. Next is, what is an enzyme? An enzyme is a biological catalyst which reduces the activation energy required for a reaction to occur. Is that right? Yet they speed up the rate of chemical reactions in organisms by acting as catalysts. They catalyze specific metabolic reactions on a cellular level. So that basically just said what I said in fancier terms. The diagram shows stages of an enzyme catalyzed reaction. Using letters in the diagram, describe what is happening. So in stage 1, the active site and the substrate is attracted to the active site because it's complementary. Stage 2, it forms an enzyme substrate complex because the substrate and the active site are complementary. Stage 3, the activation energy of a reaction is reduced. This allows a reaction to occur and two products to be created. You can mention the bond spending. A technician investigated the effect of temperature on the rate of enzyme control reaction. Is this going to be a graph question? Don't be a graph question, or I will top myself. It's a graph question, lovely. Give another factor the technician would have controlled. pH level. A quick thing, if you want to stop an enzyme control reaction, increase the temperature, increase the pH, use inhibitors, one of those. Just a quick thing I remembered. A protease is an enzyme that digests protein. The graph shows how the activity of a protease varies with temperature. Explain the shape of a curve between 30 and 50. So it shows it going down. So as the temperature increases past 30, the enzyme will begin to denature. This results in... this one's so easy, but I'm debating what to say here. This results in fewer enzyme substrate complexes being formed because the active site is no longer complementary with the substrate. So no more enzyme substrate complexes get formed. And that is it. Testing for... We don't need to test for proteins. Describe a biochemical test to confirm the presence of a protein. Okay, 2 marks. Add biurea solution to the protein solution. Add biurea reagent to the solution. A positive result will be it turning purple. Or would you say purple precipitate? I don't think you would. I don't think you say that. Yeah, if a solution turns purple, it's positive. And that is it. There you go. I've done everything. So, without further ado, I've literally just spent how long? And bro, you miss everything, man. You miss the best thing ever. No, so there you go, guys. That is all of the protein and enzyme topic done in less than half an hour. That is literally the whole last topic right there. The whole topic, 25 minutes. 5 minutes I spent just wiping my board. So 20 minutes and I've gotten the whole topic done. That means theoretically in a 1 hour exam, if you even spent a third of that thinking, you could get all of this information that I've gathered. I used no worksheets, I used nothing, I just remembered the enzyme substrate complex, the denaturing, complementary, the bonds breaking, or bending, sorry. Those are all good words to use in an enzyme question. I don't recall anything else that you would need to know. So I'm going to put my hands up, and what I will do is, I think we next have a biology lesson Thursday. Tomorrow is the exam, so what will happen is obviously we'll do it tomorrow. I'm going to make a prediction now, which might be a bit risky for me to do, because if I end up doing pretty shit, it's going to be really embarrassing. But last time I got 92% thanks to revision. So I'm going to go out and say, I want to get about 3/4 of the questions right, I think. There are a lot of nice questions that you can get marks on just for, again, using this list of words here. I could probably get a lot of marks for talking about the tertiary structure. I know the structure of proteins, like, off heart now. So any questions about protein structure, I'm going to get right. I think maybe anything about peptide bonds, condensation, I could get right. I feel like maybe some enzyme questions could be a little bit tricky. So I'm going to bet out and say 70%, maybe 65%, which is what I bet actually on the original paper too. So let's hope I do all right. And yeah, take care.